Now that we know the mathematical form of Fourier's law, let's figure out what this means about the shape of the temperature profile. Let's imagine that we have steady state, one-dimensional conductive heat transfer through a slab with no heat generation. This simply means that the slab itself is not generating heat. It is just acting to move heat from the hot side, held at a temperature T1, to the cold side, held at a temperature T2. These two dots, shown in red and blue, define those temperatures T1 and T2. We then have a heat flux from the hot side to the cold side, given by Qx double prime. So we want to ask this question: is the temperature profile curved or linear? And the way to answer that is starting with Fourier's law, that Qx double prime equals minus Kx dt dx. Because we are at steady state, and by applying conservation of energy, we know that whatever heat goes into a given slice of this slab must also then come out. This means that Qx double prime is a constant. It does not vary with x. We can then also think about Kx. We assume that Kx is a constant in the slab at the conditions of interest. What this means then is if Qx double prime is a constant and K sub x is a constant, the fate of dt dx is sealed. dt dx must then also be a constant, and the profile is then linear. We can sketch then this profile between the red dot and the blue dot. It's just a line. What would make the profile nonlinear? If K sub x was a function of x, that would generate nonlinearities. If there was heat generation or consumption, that would also cause the profile to become nonlinear.